at the ICE in Munich, I think it's almost a year ago. That was the first time I had the chance to talk to Volker from IST. And Volker, now we are here at Label Expo in Brussels, and you said to me there's no news here, right?
Thank you very much, Morten. Well, I would not say there is actually no news here. I mean, we show different things, of course, because Label Expo, a dedicated exhibition for the label printing industry, and you can clearly see the focus of what we are doing now. It's all about LED.
I was joking with you, because what I think is important to understand here is basically that when you are here at Label Expo, I take it because, I mean, everybody talks about curing systems for their labels, because it needs to be fast, it needs to be efficient, it needs to be also consuming less energy than it used to with the mercury lamps, right?
Yeah. Correct.
And what you're basically showing here, you just told me that you have a water-cooled system that fits into a housing of your existing, let's say, mercury-based thing.
Yeah.
But you can also do that even on competitors, right? So a customer can buy your lamps and retrofit it into almost anything.
Exactly right. I mean, as you know, is a huge amount of existing machines out on the market, and nearly all of them are UV presses. The label industry is the dominating UV industry. So what we decided when we developed our LED system is it's something which is not purely available for new machines. There are good machines out there. So plenty of them are equipped with our older style MBS systems. Others are equipped with systems from our competition. So we said also those customers need a solution. So we created what we call an adapter kit, meaning an LED unit plus an outer housing, which allows you to slide in a cassette in the existing housing. So the conversion of an old UV machine into a LED UV machine is technically rather simple. There is no mechanical changes implemented in that.
Fantastic. Another thing you told me before, and I have to ask you again, because you actually pointed specifically here at is it a lens or what is it?
Yes, correct.
Yeah. So when you have the lens above the LED UVs here and it has this curve,
yeah,
it's not just because it looks cool, it's also for a reason, right?
Yeah, it definitely has a reason. Even it looks cool.
Yeah.
And it's also certainly protecting everything. You see, it's exactly sealed. There is no dust, no nothing. Yeah. It's a water-cooled system. There is no dirt going inside the unit. But the main reason having this lens is that basically an LED chip provides this light like a huge curve. So it's distributed anywhere. But we want the light to hit the ink.
So with that curve, you can basically control where the light is actually...
Exactly.
Okay.
We guide the light. This is where IST is coming from. We always did a lot about reflectors. And here we guide the light to where we want to have it. And that's efficiency.
And that basically means that you can, in theory, you can use less energy for the same curing, or you can have a higher level of curing to make it faster, right?
Well, let me say no, because it's not in theory, this is in practical life. Okay. We proved it. We did direct comparisons with one of the main press manufacturers just recently, and we've clearly seen that the efficiency goes dramatically up by having a system which orients the light towards the web, towards the ink, where we want to have it.
When we met in Munich at the ICE, as far as I remember, you told me that one of the things that is very special about IST is that you do a lot of custom-built lamps, right? So correct. Is that still something you do, or is it continue to be a need for it?
It's absolutely something we still do, and we will continue to do. I mean, just behind you, you see a nitrogen inerted LED system.
This one here, or?
It's a special thing. We can have a chat about it. So that would be a very special thing if you want to cure a silicone, for example, or a special coating. It can be done in the absence of oxygen. So what you see here is just a demo model of a chill drum, the chamber, but a standard LED system. Okay. So what we do is we do customized systems exactly designed for that, but we're using standardized components on it. And the LED unit, which you see here, is exactly the same LED unit like you see it over here.
It's just utilized in a different configuration. So in this case, the lamp is more or less the same, but then it's the housing and how it's made that is different, right? Okay.
Yep.
So for a layman like myself, when I look at something like having a light that is cured, of course it's the photo initiators in the ink that actually cures, right? But when you look at that, I mean, there's a certain spectra you need to dry in. How does that look? Because I mean, you need to focus as much energy as possible in order to make sure that you have that. But I was also thinking that if you had like, let's say a more, let's say spectral spread of the light, maybe you could have less photoinitiators in the ink.
I mean,
Is that right? I'm just guessing.
It's practically right what you're saying. The wider your spectrum it is, the easier it is for the ink or coating or whatever varnish formulation. On the other hand, the more narrow it is, the better the ink matches on that, the better your efficiency will be at the end of the day, because you're using all the energy which the system provides for the curing. So this is the tricky balance.
So what you basically say is that when you have the arch where you have like the lens that is focusing, then you basically want a very consistent ink with a consistent level of photoinitiators, because that's the optimum of the lamp basically.
That would be the optimum, and this is certainly what we like to do.
Yeah.
But we always need to find the perfect match between the physical side, what we provide, and the chemistry side.
Yeah.
I mean, there is raw materials involved, there is things like reach involved, there are plenty factors which need to be considered. But all in all, the whole industry is now going towards some standard, let me call it, wavelengths. So it's more and more the 385, 395, 365, which gets the common wavelengths.
And that's funny you mentioned that, because last time I saw you, we didn't talk much, but that was the IST UV days, right?
Yes.
Because that was like among your partners, there was quite a few, I think like at least a couple of ink manufacturers, right? And I take that, of course, it's very important for a company like IST to have close relationship with the people that creates the ink, so you are like aligned in production, right?
I mean, we need to do that. On one hand, we need to consider what can they provide. It has to be workable. On the other hand, also it's always a bit of a balance. It needs to make their life not too complicated, but a little bit complicated, giving a bit of pressure to develop in the right direction. And we are happy to really see. I mean, on UV days, we had this example, not a label industry, it was commercial industry, of a customer which is today printing with speeds of 12 meters per second, equals 500 meters per minute.
Was that on the commercial side?
On the commercial
was
side.
that the Hooper ink with the magazine that was printed? Because
Correct.
I saw that was amazing to see.
It
right?
was a Hooper printing ink, printed on a Königenbauer rotary press, where they print magazines and leaflets and stuff like that in a speed where we would have 3 years ago said, or 5 years ago, we would have said, forget it's impossible. Today it's reality. It's about performance of the system. It's the performance of the ink. And that's
last question I have, and that might relate a little bit to that, because I mean, obviously LED UV requires some energy.
Correct.
If you have, let's say on the commercial side, you have the gas ovens, also require some energy. What is the ratio in energy consumption? If you were able to do like replace a web offset machine with LED, what is the ratio on energy consumption?
This is one of the most complicated questions, because especially compared to a gas oven, there is such a big impact of other factors. If somebody has very long runs, the gas ovens are extremely efficient. But are runs getting longer in the commercial? No, they're getting shorter.
So you mean it's more a question of time before it is more valuable to use the LEDs, basically?
And then the shorter runs get, the more interesting it is, because an LED system allows you to use the energy when you need it. There is no preheating, there is no afterheating, there is no temperature stability which needs to be achieved. It's there when you need it, and it's off when you don't need it.
And one last thing is that what I liked when I saw the replacement of the gas ovens with the LEDs was maybe even more interesting to see that the heat, of course, obstructs the paper to some extent. Here you have flat papers that comes flat in, flat out, right? Because you don't have the temperatures, right?
That's
and
a
the water, of
a
course,
perfect
right?
situation in this business. I mean, but vice versa. On the label industry, I mean, we are talking about labels here. We are printing on very, very thin film material, which is sensitive in regards of temperature. And all the machines, great machines, but they are all built with chill drums. And a chill drum is a massive material which you need to speed up, which you need to ramp down, which you need to cool. All that is wasted energy. And by using LED, the amount of temperature into the material is extremely small. So all these very costly and energy consuming chilling devices up to a huge extent can be eliminated.
Fantastic.
So there's a lot to do.
Thank you, Volker.
Morten, good to meet you again.
Good to meet you again.
Enjoy Label Expo and hopefully with a bit more cooling in the halls.
I think we will lose weight here.